Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Find the derivative of the following function with respect to the corresponding independent variable. The function that we have is y equals sine of x degrees, right? We know what is dy by dx of sine x, right? It's cos x. So we've seen that using first principles. But here we have x not in radians but in degrees, right? So it calls for a quick conversion of x in degrees to x in radians, right? So we will have to do that before we actually go about solving this problem because all the trigonometric identities that we know of, be it in trigonometry or be it in differential calculus, we assume that x is in radians, right? So d by dx of sine x equals cos x, it means that x is in radians. So if x is in degrees, then we have an opportunity to apply the chain rule of differentiation here. So we do d by dx of sine into d by dx of x in degrees, right? But before that, let's convert it into radians, right? I know my 1 degree in terms of radians. So let's write that out. So my 1 degree is equal to pi by 180 radians, right? So what is my x degrees, right? It's nothing but I'm just going to replace my 1 by an x. So please watch it again. 1 degree is equals pi by 180 radians. Then my x degrees equals x pi by 180, right? That's how I convert this into radians, right? So now I can rewrite my y. Now I know how to solve for this. I can directly apply the chain rule of differentiation. So what is my y dashed? Y dashed is nothing but d by dx of sine, which is a cos, and I retain the expression within sine as it is because I'm differentiating this with respect to x pi by 180 degrees. So I don't have to worry about that, right? And then I do a d by dx of x pi by 180, right? So what is that? That is pi by 180 into d by dx of x because my pi by 180 is a constant and I can pull that out and I'm left with d by dx of x, which is 1, right? So my final answer to this particular problem is times cos of, sorry, pi by 180 times cos of x pi by 180, right? So that's the final answer for this particular problem. And again, a useful example for chain rule of differentiation. And for those of you who have not been able to completely comprehend what did I exactly do, I'm going to place my chain rule here and tell you what exactly we did, right? If my f is a function which is y equals f of g of x, and what is my dy by dx is dy dx of f of g of x, wherein I differentiate my f with respect to g of x first, and then I go about differentiating my g of x with respect to x, which is my g dashed of x, right? So in this case, what is my g of x? My g of x is nothing but x pi by 180, right? So let me highlight it. So that is my g of x. So I did a differentiation of the function f with respect to g, which means with respect to x pi by 180 degrees. So I just so that's my cos of x pi by 180. And then my second part, which is a g dashed of x, like I mentioned earlier, my g of x is x pi by 180. So my g dashed is my pi by 180 is a constant and d by dx of x is 1. So that's how I arrive at pi by 180 into cos of x pi by 180 for this particular problem. So again, a good example of chain rule of differentiation. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.